Hello, this is Nishchita. I am a student of Enviro Poly and I am making this video as a part of my homework for probability and stochastic processes, homework 3. Here is the question 2. The question 2 says x is a uniform in between the values minus 1 and 2 and y is given as x square. And part A of the question 2 asks us to find and draw fx of x, which is the distribution function of x. So in order to find fx of x, we can take fx of x is equal to integration of minus infinity to x fx given function into dx. So the given function can be written as a uniform between minus 1 and 2, which is like this. We can from this given function we can get the density function of fx of x to be 1 by 3 for x in between minus 1 and 2. So in order to find the distribution function of x, we can take fx of x is equal to integration of minus infinity to plus infinity fx of x into dx. So on integration we can find that for any value of x less than 1, fx of x will be 0. For value of x lying between minus 1 and 2, fx of x will count to x by 3 plus 1 by 3. And for any value greater than 2, for any value greater than 2, it will be 1. So this can be represented in a graph as such. So if you take distribution of function of x, you can represent it as from minus 1 to 2, it is an increasing function with 1 by x by 3 to plus 1, x by 3 plus 1 by 3, and below minus 1 it is 0, and after minus 1 it is a constant value and it stays on 1. So the part B is to find the density function of y, which is fi of y. So we know that density function can be taken as probability of y staying less than y. So we know y is x square, so you can substitute that. So p of x square less than y. So y of x y square y is equal to x square can be drawn as this. This is a parabola function, and it has if you drop the perpendiculars, it will come up to on the positive side it is plus root of y, and on the negative side it is minus root of y. So we know all you have to do is just substitute that. So it will become p of square root of minus y less than x less than positive square root of y. Yeah, so this is where y basically exists. So if you take fx of square, it will come up to fx of square root of y minus fx of square root of minus y. So we know that x ranges from minus 1 to 2, so we can take that y ranges from 1 to 4. So for 0 to 1, fi of y will be fx of x by divided by g of x, but is nothing but 1 by y by square root of y plus 1 by y by square root of 2 square root of y, which comes up to 1 by 3 square root of y. So similarly for 1 to 4, it will come to fi of y will be fx of x by gx of x mod, which comes to 1 by 6 square root of y. So it can be written as for 0 to 1 it is 1 by 3 square root of y, for 1 to 4 it is 1 by 6 square root of y, and for 0 it is otherwise. So this can be represented in the form of a graph as shown. So for 0 to 1 it is a decreasing function from 1 by 1, that is 1 by 3 square root of y, and at 1 it drops to 1 by 6 square root of y, and from there it's again a decreasing function till 4, and after 4 it goes to 0. So the question C asks us to find the distribution function of y, that is fy of y. So in order to find that, we take fy of y is integration of minus infinity to y fy of y dy. So we know that for y is less than 0, fy of y is 0, and for the interval 0 to 1, fy of y is integration of minus infinity to y 1 by 3 square root of y, which is 1 by 3 square root of y can be taken as y to the power of minus 1 by 2. So on integration and applying the limits, you'll end up with 2 by 3 square root of y. So similarly from 1 to 4, you can take it as integration of minus infinity to y 1 by 6 square root of y. Similarly, if you apply if you integrate and then apply the limits, you'll end up with 1 by 3 square root of y plus 1 by 3. So if that is written in the form of an equation, so fy of y will be 0 for y less than 0, 2 by 3 square root of y for the interval 0 to 1, 1 by 3 square root of y plus 1 by 3 for the interval 1 to 4. So that can again be represented in the form of a graph as shown. So you have 1 by 3, 2 by 3 and 1 on the y-axis. So it is 0 below 0. It is an increasing function of 2 by 3 into square root of y for 0 to 1, and after that is again an increasing function of 1 by 3 square root of y plus 1 by 3 for 1 to 4, and then it's a constant. The part D asks us to find e of y with e of y. So e of y can be taken as e of x square. So it is an integration of minus 1 to 2 x square into the density function, that is 1 by 3 into dx. So 1 by 3 into x cube by 3, which come with the limits of minus 1 to 2. So 1 by 3 into 8 by 3 minus of minus 1 by 3, which will come to 1 by 9 into 8 plus 1, which is 9. So it will come to 1. So E of y value is 1.